I got a request to make a sewing machine part. It's for an industrial Singer sewing machine that's from the late 1930s. The parts for this machine are hard to get or nearly impossible to get. And the machine gets used almost on a daily basis to make cargo netting. It's called a stop cam interlock rod. And from what I understand, when the machine finishes its cycle, it stops the machine. It fits inside this housing, and I don't have anything but a picture to go on for what it's supposed to look like. So all I can do is take measurements and try to guess at the tip on how it's supposed to be made. It's all pretty much intact except for the tip where it makes contact with the stop cam. They also wanted me to make this screw. It's an oddball size between a number 10 and a number 12 screw, and it's got a 32 pitch thread. This is the picture I have of the stop rod. You can see the one that's damaged below the picture. I used Photoshop and made a grid pattern to help with the dimensions. I wish I was better at Fusion 360 because that probably would have helped a lot. The outside diameter of the rod is 3/8, so I had a scrap piece that I could use. I mounted it in a 5C collet and a square adapter. So now I'll use the DRO and edge finder to find the one edge and the front side. On the tip there's a flat area. So I calculated from the point to where it starts to rise is 0.077. And the depth will be 0.111. It looks like the angle on both sides is 20 degrees. So I'll loosen the vise and rotate it to the 20-degree mark. So the distance from where the flat ends at 0.077 is 0.393. So using the vise stop to maintain the distance, I'll flip the piece over 180 degrees. There isn't a flat on this side of the stop rod, so it'll be a 20-degree cut all the way through. Next, it looks like there's a radius on the very tip on the opposite side of the part that's flat. Next, I need to work on this area of the top side of the stop rod. It looks like it angles back from the tip, so I'll use my angle gauges to try to find the right angle. Using the grid pattern that I made, it looks like it's going to be a 3-degree angle. So I put the angle gauge in the vise, and I set the vise rotation back on 0 degrees. I'm still using the vise stop to locate the workpiece. I used a red magic marker just so a visual reference. By taking measurements on the old piece, it looks like the cut ends at the same place that the other cuts that I did at the 20-degree angle end. Next, I need to work on this area. I measured back from the tip to where the cut starts, and it's 1.381. The distance from front to back is 0.445, and the depth is 0.085. Next, I'll work on this area. The distance from the tip to where it starts is 0.470, and the length of cut is 0.629, and the depth is 0.015. I seem to have misplaced the footage of me making this cut. Next, I need to turn down the back end of the stop rod. The distance from the point to the rear end of the stop rod is 2.986. The length of cut is 0.403, and the diameter is 0.340. I'm using the 5C chuck on my lathe and the 3/8 5C collet. So here's the damaged part on the left and the new part on the right. So looking at the side view, It doesn't look like I cut as far back on the angle as the original one. I'm not sure if it's going to matter because where it makes contact with the stop cam is more towards the point. And here's the view on the other side. I'll try and show just from the picture how this works in the sewing machine. So this is the stop cam. So when the sewing machine finishes its cycle, this cam stop rod moves into position. And then the cam rotates and stops the machine. So here's the point of contact with the stop rod. They physically showed me the machine, so I saw how this part works, but I don't know anything about the rest of the sewing machine. So I don't know if it was constant wear that caused the tip to break off, or if there's some kind of timing issue where the machine is still trying to run when the stop moves into position. I still need to harden and temper the new part that I made, but I'll wait until I finish making the screw and just do them both together. So now it's time to start on the screw. The head on the screw is a 1/2 inch in diameter, so I'm just going to use a 1/2 inch bolt to make the screw. The outside diameter of the threads is 0.199. The thread diameter of a number 10 screw is about 0.187. And a number 12 screw is about 0.208. So the screw is kind of an oddball with a 32 pitch thread. The thread length is about 0.189. I set up the lathe to cut a 32 pitch thread. I'm going to leave the half nut engaged, and I'm just going to turn the chuck by hand. It's kind of an odd way to cut threads. The screw is so tiny it seems like the safest way to do it. I have the carriage stop set so I can run the threads all the way up to the bottom of the screw head. Luckily, they gave me the piece that the screw screws into so I can test fit it. Looks like a good fit, so now I can part it off. The screw is a little bit dome-shaped on the top, so I'm going to adjust the compound so I can cut a taper on the top of the screw. Next, I'll use the slitting saw to make a screwdriver slot. This is where having a DRO on the quill comes in handy. So now all I have to do is divide that in half. Now it's time to harden and temper the screw and the stop rod. After this, I tempered the parts in the oven at 450 for about 20 minutes. Now it's time to assemble the parts. This flat plate fits in that slot, and that locks the stop rod in place. It locks into this pocket on the stop rod. So first the spring goes in, and then the stop rod. I'm going to compress the spring up against the side of the vise and put the locking plate in place. The screw that I made holds that plate down tight, so it holds everything together. There's enough clearance under that plate to let the stop rod move back and forth in that pocket. So it's all finished, so I think it was a success.